Have you ever wondered what a tree trunk goes through before it becomes perfectly finished lumber? In today's episode, we'll follow that journey through massive machinery, state-of-the-art production lines, and the skilled people who have devoted their lives to working with wood. From Sierra Pacific and Britain Lumber in the United States to Dorotea Såg in Sweden, each stop offers a unique glimpse into the modern timber industry. Join RaWMachines as we explore this fascinating process together. The journey of every wooden plank doesn't begin inside a factory, but deep within the vast forests of Oregon. This is the homeland of towering Douglas firs, many of which have stood and grown for decades, if not centuries. Out here, the forestry harvester moves not as an intruder, but as a decisive mechanical craftsman. Once a target is selected, its hydraulic grappling head clamps firmly around the trunk, while a circular saw blade underneath swiftly fells the massive tree in a matter of seconds. Yet, felling is only the beginning. Instantly, a system of specialized delimbing knives strips away branches and limbs, while the feed rollers advance the trunk to be cross-cut into standard-length logs. The entire sequence unfolds almost seamlessly in a single, closed-loop automated cycle. Inside the climate-controlled cab, wrapped in modern electronic displays, the operator monitors every critical parameter, such as log length, diameter, and real-time timber volume. With just a few precise movements of the joysticks, they control the entire operation with incredible accuracy. No piece of wood is without value. That is their core philosophy, utilizing every single inch and every grain of timber, ensuring that no part of what nature provided goes to waste. As the first logs are loaded onto the trucks, their journey out of the forest officially begins. The loading process is handled by heavy-duty hydraulic cranes mounted directly onto specialized transport rigs. Timbers weighing tons are hoisted into place with absolute precision. Leaving the harvest site behind, the logging trucks navigate a rugged, challenging network of forestry roads. Most of these trails are unpaved, featuring steep inclines and surface conditions that shift constantly with the weather. Because of this, the drivers maintain a cautious, low speed to guarantee safety throughout the haul. Gradually, the wilderness gives way to the industrial landscape. Steel perimeter fences, massive log yards, and sprawling mill structures begin to emerge ahead. Here, a brand new transformation will take place. The journey of turning raw logs into high-value products that serve human life. And our very first stop is one of the most advanced sawmills in the United States, Sierra Pacific Industries. Founded in 1949, Sierra Pacific Industries has grown into one of the largest private forestry empires in the United States and a benchmark for sustainable forest management. Here, every single log is identified and categorized before entering production. Information regarding dimensions, origin, and species is logged directly into a central database. This tracking system allows the mill to trace the journey of each individual tree trunk, from the harvested forest block all the way to the final product. The processing journey begins with the removal of the rough outer bark using a ring debarker. A sensor system continuously measures the diameter of each log, allowing the hydraulic cutting tools to automatically adjust their position and closely follow the wood's surface. Within seconds, the thick bark is cleanly stripped away without affecting the wood beneath. The process happens so quickly that observers can only catch glimpses of bark sections continuously falling onto the conveyor below.
Open them up, open.
At Sierra Pacific, however, bark is not treated as waste. It is immediately collected through a network of conveyors and industrial air handling systems. The material is then processed into landscape mulch, or used as fuel for biomass boilers, which help generate energy for the mill itself. After debarking, the logs enter the heart of the mill, the primary sawing area. One by one, they are carried by conveyor into the head rig, home to massive bandsaws stretching more than 15 meters in length. Operating at tremendous speed, these machines can cut through large logs in a matter of seconds. Contrary to what many people imagine, the operators do not stand beside the saws. Instead, they work from enclosed control rooms, monitoring the entire process through multiple electronic displays. From there, they track cutting patterns, production speed, and system performance, making constant adjustments to maximize efficiency. One of Sierra Pacific's most innovative technologies is its curved saw system. In nature, very few trees grow perfectly straight. Many develop natural curves, and cutting them along a straight line can result in significant material loss. The curved saw addresses this challenge by using sensors to map the shape of each log, and then guiding the cut along its natural grain orientation. As a result, lumber recovery is significantly improved. By the time the logs leave the primary saw line, they have been transformed into squared timber cores, sideboards, and the wood chips generated during processing. From there, every piece continues down the conveyor system toward the edging and trimming line, where the final shape of the lumber begins to emerge. The edger takes over like a master craftsman, removing the natural curved edges of the boards and transforming them into straight, parallel pieces of lumber. None of the trim material goes to waste. The offcuts are sent directly to chipping systems, where they are processed into wood chips for the paper industry and biomass energy production. Next comes the trimmer line. Dozens of saw blades are positioned along the conveyor at fixed intervals. Depending on the required board length, only the necessary blades are activated. This approach maximizes product yield while minimizing the amount of wood that must be removed. No matter how advanced the machinery becomes, the ultimate value of every single board is still decided by the sharp eyes of human experts. Professional lumber graders directly evaluate every wood grain, knot, and surface defect in accordance with the ALSC standards, the national U.S. grading system established back in the 1920s. This critical step does not just dictate the commercial value of the timber, it ultimately decides the structural mission of each board in future construction projects. The final, yet most delicate, step in the entire process is kiln drying. Here, each neatly stacked bundle of lumber undergoes a rigorous purification, lasting over 10 days and nights, to completely shed internal residual stresses and natural moisture content. Within the silent chambers, thousands of sensors act as silent eyes, monitoring every breath of the timber to ensure absolute structural stability. This careful regulation guarantees that the wood will never warp, twist, or check, even when subjected to the harshest climatic fluctuations. Following the drying process, the timber takes on a subtle golden hue. Its grain patterns become strikingly pronounced, and it emits a distinct clear ring when tapped. This is the ultimate sign of completion, marking the end of a perfect life cycle as the wood transitions from the wild forest to a finished product. Leaving behind the immense scale and steel-clad discipline of Sierra Pacific, we now turn toward the historic forests of New England. If Sierra Pacific represents the power of modern industry, then at Britain Lumber, the story of wood is told in a very different way. One where technology steps back, allowing craftsmanship, teamwork, and human experience to take center stage. At Britain Lumber, the business chooses not to chase aggressive scaling. Instead, it focuses on striking a careful balance between commercial efficiency and the value of true craftsmanship. The philosophy here is remarkably clear. Technology is born to assist, not to replace the human touch. The true beating heart of Britain Lumber is a traditional sawing layout featuring a primary head rig, 2 heavy-duty gang saws, and a specialized resaw. Even with modern technology retrofitted over the years, this production line proudly retains the classic characteristics of historic North American sawmilling. The moment a log is hoisted onto the log carriage, the sawyer must quickly evaluate its geometry, natural sweep, and internal quality. Drawing upon decades of collective intuition, they instantly lock in the optimal cutting orientation to extract the maximum yield of high-value timber from the log. After passing through the head rig, the timber is no longer a round log, but has been squared off into heavy blocks known as cants. However, this is merely the initial transformation. These cants are then routed directly to the resaw system to be sliced into finished boards. This setup utilizes multiple bandsaw blades running simultaneously, allowing a single block of wood to be broken down into several individual products in a single pass. This stage is widely considered one of the most critical puzzle pieces affecting the entire mill's overall throughput. When dialed in with absolute precision, the resaw maximizes the volume of commercial-grade lumber reclaimed from every single log. After sawing, the boards are sorted to determine their next stage of processing. Boards that already have square edges are sent directly to the trim saw, while those that still retain their natural rounded edges are routed through the edger. The edger uses an optimization scanning system to identify the most efficient cutting path, removing the rounded edges and producing clean, square lumber. This not only improves the appearance of the final product, but also maximizes lumber recovery. Once edging is complete, the boards move to the trim saw, where operators grade each piece and cut it to standard lengths. Once the boards have been cut to size, they are sorted by width and grouped into uniform batches before entering the kiln. Workers carefully stack the boards in layers, placing small spacer strips known as stickers between each course. Simple as they may seem, these strips play a critical role by creating air channels that allow heated air to circulate evenly throughout the stack. Once the bundles are loaded into the kiln, the drying process begins. Over the course of several days, temperature and airflow are carefully controlled to gradually reduce the wood's moisture content to the required level. This is one of the most important stages in the entire process, determining the long-term stability of the lumber and helping prevent warping, cracking, and shrinkage once the wood is put into service. One of the most remarkable aspects of Britain lumber is its commitment to using every part of the resource. Throughout the milling process, various byproducts are generated, including side slabs, edging offcuts, and trimmed wood sections. Rather than being discarded, these materials are collected and sent to the chipping system. They are then transformed into raw material for the paper industry and a wide range of engineered wood products. Meanwhile, sawdust and bark are repurposed for agricultural use and other industrial applications. Through this approach, virtually every part of the log is put to use, creating new economic value from what might otherwise be considered waste. After kiln drying, the lumber passes through the planer mill for final surface finishing. This stage smooths the faces, refines the edges, and shapes the boards to the required specifications, preparing them for construction, interior finishing, and exterior applications. At the end of the production line, workers inspect each board, assign quality grades, and then bundle, package, and label the finished products. From the company's main facility in Fairleigh, dozens of truckloads leave every day delivering lumber to customers throughout the region. Although modern technology and artificial intelligence are playing an increasingly important role in manufacturing, Britain lumber continues to maintain a balance between innovation and traditional values. Every board that leaves the mill reflects the dedication of skilled craftsmen, proving that people still remain at the heart of modern wood processing. Now, let's head to the final stop on our journey. Dorotea Såg, a sawmill in northern Sweden. This is a harsh environment where winters are long and temperatures frequently plunge below -25 degrees Celsius. These unique natural conditions produce trees that grow far more slowly than those found in milder climates. Their growth rings are tighter, their wood density is higher, and their grain structure is more uniform. The result is a raw material renowned for its strength, stability, and exceptional surface quality. The moment the logging trucks roll into the facility, the strict material control process immediately swings into action. Every incoming payload must pass over an electronic weighbridge scale before it is cleared for production. At this station, key parameters such as weight, length, and diameter are automatically captured. This data is instantly transmitted to the central management system, allowing the mill to track with pinpoint accuracy the exact volume of raw material moving through the pipeline. Following the initial weighing and measuring, each individual log is assigned its own unique identifier. This digital footprint is securely logged, ensuring total traceability across every single stage of the manufacturing process. Based on their dimensions and geometric profiles, the logs are sorted into distinct groups and routed to their corresponding storage bays. This sorting phase optimizes downstream efficiency and drastically minimizes production errors on the main lines. As in most sawmills, the logs first pass through the debarking stage to remove dirt, debris, and any embedded metal that could jeopardize both safety and production efficiency. Even a small piece of metal hidden inside a log can severely damage high-speed saw blades worth thousands of dollars. That is why raw material preparation and cleaning are carried out with exceptional care and strict attention to detail. If there is one technology that defines Dorotea SOG, it is undoubtedly the HewSaw system. Unlike the multi-stage sawing processes commonly found in traditional sawmills, HewSaw integrates multiple operations into a single, highly automated production line. Thousands of data points are collected in an instant. Advanced scanning systems generate an accurate 3D model of each log, capturing every curve, taper, and natural geometric feature. The system then determines the cutting strategy that delivers the highest economic value while maximizing lumber recovery. Within seconds, a log enters one end of the line and emerges from the other as bright, flat, precisely dimensioned boards. It is a powerful example of how modern technology is transforming the global wood processing industry. Despite the high level of automation throughout the mill, the role of human expertise has never disappeared. In the grading area, experienced inspectors continue to evaluate the color, grain structure, and surface quality of every board that passes through the line. Many critical characteristics still rely on human judgment and real-world experience, qualities that machines cannot fully replicate. After grading, the boards advance to what is widely considered their ultimate tempering process. First, the lumber is bundled into massive stacks, separated by thin wooden spacers known as stickers. These gaps allow heated air to flow evenly throughout the entire payload. The stacked lumber is then transferred into massive, computer-controlled dry kilns. A sophisticated network of sensors constantly monitors the internal temperature, relative humidity, and air velocity throughout the entire run. Depending on the specific wood species and dimensions, the drying cycle can span anywhere from several days to multiple weeks. Over this period, the internal moisture is gradually stepped down under strict regulation to prevent checking, splitting, or warping. Upon completion, the timber's moisture content typically drops to a precise 6 to 8%, the ideal threshold for high-end construction and premium interior joinery. At this stage, the boards are not only significantly lighter, but they are also far more structurally stable and durable, fully seasoned to withstand environmental shifts throughout their operational lifespan. Moulidoul Impex SRL is one of Europe's premier oak processing facilities. Their raw material is sourced from sustainably managed Romanian forests where oak trees typically take between 80 and 150 years to reach harvestable quality. This slow growth process creates a tight grain structure, high tannin content, and legendary durability, factors that make it a highly prized commodity on the international market. When the logs arrive at the sawmill, they are stacked into large stockpiles and sorted according to diameter, core quality, and intended use. Cat wheel loaders move constantly between the log piles, unloading, transporting, and feeding logs into the processing line. In addition, workers carry out an initial preparation stage using handheld chainsaws. Rough butt ends, cracked sections, insect-damaged wood, and logs that do not meet the required length specifications are removed beforehand. Although this step may seem simple, it plays a crucial role in reducing material waste, protecting cutting equipment from unnecessary wear, and optimizing the final products to meet specific customer orders. As the log enters the vertical band sawmill line, raw mechanical power takes full command of the floor. The timber is locked tight by heavy-duty hydraulic dogging clamps onto the log carriage feed system, while sharp red laser guides project onto the surface to pinpoint the optimal opening cut, ensuring the mill extracts the absolute finest grain patterns from the log. The entire operation is actively monitored via digital control screens, allowing the technician to make real-time adjustments to the feed speed, board thickness, and general operational parameters with pinpoint accuracy. Leaving the primary saw line, the timber continues through the multi-blade edging system. The objective of this stage is straightforward: to completely remove the rough outer bark and sapwood, preserving only the high-quality heartwood within. The edgers use multiple independently adjustable circular saw blades, allowing them to process even irregularly shaped boards efficiently. The system operates with remarkable precision, maintaining a tolerance of only about 1/32 of an inch, roughly 0.8 millimeters, a critical factor in ensuring dimensional consistency across the entire production batch. Once completed, the timber pieces continue along an extended conveyor system toward the manual inspection area. Under grading lights, workers examine every crack and even the smallest imperfections before sorting and bundling the material. The leftover wood is not wasted. Instead, it is diverted onto a separate conveyor line, ready to begin a new cycle of recycling and reuse. If sawing timber is a display of strength, then kiln drying is the ultimate test of patience. Because of its dense cellular structure and high tannin content, oak cannot be dried too quickly. If temperature and humidity are not carefully controlled, the material can easily suffer from surface checking, warping, or case hardening, a condition in which the outer layers become dry and rigid while the core remains excessively moist. For that reason, the process typically lasts between 30 and 60 days, long enough to reduce the wood's moisture content from its green state to levels suited for specific applications, around 6 to 8% for high-end interior work, or 12 to 14% for structural and load-bearing uses. After drying, the timber undergoes a preservation treatment stage. A still forklift transports entire bundles into a bath of specialized chemical solution, allowing protective agents to penetrate deep into the wood fibers. The result is a significantly stronger defense against termites, insects, and the long-term effects of outdoor exposure. Once out of the kiln, each board is no longer a piece of raw timber. Moisture levels are rechecked using electronic sensing equipment to ensure complete consistency. Workers use handheld plastic strapping machines to transform hundreds of individual pieces into solid, unified bundles. One of the signature images that defines Muladul is the sight of workers spraying red dye onto the ends of the timber bundles. Red coating is not merely a statement of brand identity in the international market. It is also an elegant technical solution. It creates a barrier that slows excessive moisture loss through the end grain. In this way, people safeguard the results of their labor, protecting the timber from even the smallest cracks until it reaches the end user. Before shipment, every bundle receives its own identity through laser measuring systems and handheld scanners. Specifications such as 60 millimeters thickness, 1.30 meters length, grade A, and a volume of 1.34 cubic meters are clearly printed on the label. This transparency serves as the passport that allows Romanian oak to enter the global market. The final stage is a display of precision and efficiency. Modern lean forklifts move with agility, carrying timber bundles deep into 40-foot shipping containers operated by Yang Ming. Once the container doors close and the security seal is attached, a new journey begins. Powerful Volvo FH500 tractor units will haul these legacies away from the factory toward the seaport. This is more than an industrial production process. It is a testament to sustainable development. From a young sapling deep in the forest to timber meeting stringent international standards, Muladul oak has fulfilled its mission to become the backbone of durable structures around the world. If Muladul Impex in Romania represents the industrial scale of oak processing, then Andrei Sawmill carries a very different rhythm. Located in Saint-Ferréol, in the Haute-Savoie region, Andrei Sawmill is a family business that has operated across more than 4 generations. Though it does not pursue massive industrial scale, it continues to hold an important place within the alpine timber industry through deep specialization and strong ties to local raw materials. Its primary timber supply comes from the high mountain forests, spruce, silver fir, and larch. For centuries, these species have helped shape the distinctive identity of the Alps, from mountainside chalets to historic European architecture. As the logs enter the line, the alpine timbers are processed by a high-capacity bandsaw system. This serves as the primary breakdown stage, stripping away the rough outer bark to reveal raw, unrefined boards that showcase the unique color and grain characteristics of high-altitude timber before they are automatically conveyed into the refining zone. At Andre, tradition does not mean outdated methods. The heart of the sawmill is a modern control cabin where technicians operate the entire production line through joysticks and high-resolution monitoring cameras. The real marvel lies in the 3D laser scanning technology. Before the saw blade even touches the timber, the computer has already simulated the optimal cutting strategy based on the actual shape of each log. This technology not only minimizes waste, but also ensures that every precious millimeter of wood is utilized according to its true value. If the craftsman's hands embody experience, then 3D laser technology represents the fairness that humans extend toward nature. After the primary breakdown stage, the timber moves into the finishing area. The edging system takes over the task of refining board width, removing irregular edges, and producing timber pieces with more uniform dimensions. The production line operates almost continuously. Boards are automatically flipped to inspect both surfaces, allowing the system to evaluate surface quality, detect defects, and classify materials according to production standards. Alongside conventional products, Andre also manufactures many traditional structural components such as timber frames and large 8x8-inch beams, elements that continue to play an important role in European timber architecture. The atmosphere in this part of the mill is remarkable. Freshly cut spruce carries a clean, resinous aroma, slightly sharp with the scent of sap, which seasoned workers say they never grow tired of.